Right. So first of all, let's understand the integral, the meaning of the integrals. Right. The integral, this is the simplest integral, okay, dx. Okay. So that actually is the integral of 1. This is an integral of 1, and you know that the antiderivative of that is just x and plus constant. So this is the simplest integral, okay? And then we have to understand what is dx. Okay, this is called the differential of the variable x. So what is x? What is dx, right? First of all, you should tell me what is x. If you are giving me the information about x, then I know what is dx, right? So question is, what is dx, right? Let's understand this. If x is ft, okay, then dx is going to be f prime t dt. Okay. So if we put it into above formula, and you will see that dx is replaced by f of t, and then x is f of t. This is a well-known formula, but it's more general form, right? So this is part is dx. This is just x. Okay. So you can get all the formulas you need from the very top one. Okay. Now, in some abstract way, if x depends on another variable, then you don't need to mention f of t. So in general, you can always write in this form if you think x depends on t. Okay, this looks trivial, right? If you use the derivative of the quotient, then this just dt cancels out. Okay? And you can continue if t depends on s, then you can write like this. Okay, so it's a sequence. So you get a chain. Right. You can also both sides divide by ds. Okay. Then dx ds is going to be dx dt, dt ds. So that's called the chain rule, right? We know that. That's called the chain rule. So when you differentiate x with respect to s, then you introduce a parameter between x and s. Then you make its relationship simpler. The relationship between x and s is very complicated, but if you introduce the variable between them, then we're much easier. You know, the relationship between x and t is simple. The relationship between t and s is simple. Then you can quickly find the derivative. Okay, a good example is, for example, if x equals, okay, if x equals the square root of 1 plus t squared, all right, 1 plus, let's use s. Yeah, we're using s here. Yeah, 1 plus s squared, let me rewrite. Okay, so how do you do that? Well, you can express it like a t, where t equals 1 plus s squared, right? So the relationship between x and t is simple. The relationship between t and s is simple. T is viewed as like a midpoint. So dx dt and dx ds is going to be dx dt and then dt ds. Okay, that's by the channel. So here's x can be written as like this, right? Then you differentiate with respect to t, and here's ds. Okay. So you can cancel. That's a review of a chain rule. Okay, and so you cancel 2, and t is going to be, you can write t in the form from s t to the 1/2, right? So what is t? T is 1 plus s squared. So you get this by the chain rule. But now our focus is today is on the applications of the integral. Okay. So x could be the product of two functions. X depends on u and v. Okay. And the u depends on something else like a t. Okay. Okay. And here u and the t. But right now just two variables. Okay. So how can I write a dx? So x depends on u and v. U and v depend on some variable, so maybe t. So then we have the product rule. Okay. So the derivative u v plus u dv. Okay. This is a product. Okay. Right, product. You can put the dt under each term. You can get derivatives. Okay, but right now let's put the integral symbol. Okay, what do you get on the left hand side? It's just x, right? X, I know that's going to be x plus c, right? So x plus c. Yeah, so usually you write c, okay? And the x is going to be uv plus c. So I got the following information, okay? Integral u dv is going to be u plus v plus c minus du and v. I can, since also this contains c, constant c, so I don't need to put a c there. So this simply can write uv minus v du, okay? Yeah, I don't need, I can drop the constant c because it's indefinite integral always contains another constant c. So this is the so-called integration by parts. Okay, it's a very useful formula. It's a very useful formula. So we're going to use that practice, okay, on a number of the problems. We know the derivatives of many functions, right? So we want to find out the integral of, like this one. This is, we don't need we just need the formula. There's no need integrated parts, right? So we know this is going to be 1 over n x to the n plus 1 if n is not going to be -1, okay? Otherwise, you get a new function, okay? You get new function like x to the -1 is going to be natural log of 3x plus c, okay? Since we know the derivative of this function is going to be 1 over x. We also know that if it's integral of e to the x, and that will be e to the x itself plus constant. And so, but we already learned many. We already learned many new functions like a natural log, right, and sine, hyperbolic sine, hyperbolic cosine. So my question is, how about natural log of the integral of natural log x dx? Yeah, this is a I don't know, right? So I don't know the antiderivative of this function. Okay, I don't know the antiderivative of this function. All right. So we have to do something to get the antiderivative. I search for all the possible formulas, all the formulas we already learned. for the derivatives of elementary functions. I don't see something the derivative equals natural log of x. All right, so how do I do that? This will be called u, that's the dv, okay? So in other words, u is natural log of x, v is x. You put, and by integration by parts, it's uv minus v du, right? It's switched. Now, since u equals natural log of x, so du equals the derivative of u with respect to dx, right? So the derivative with respect x is 1 of x dx. So now let's put the details here. U is natural log of x, v is x, v is x, then the derivative, then du is 1 of x dx. Great. So x canceled out, you get constant. The constant is just equal to x, and then plus constant. So this is the answer. So the entire derivative of natural log of x is not a simple function. It's natural log of x times x minus x. Yeah, it's hard to imagine without using integration parts, how do we solve the problem, okay? So when you see a natural log in the integral, it's not easy to find antiderivative. The only way you can find antiderivative using the formulas is to get rid of natural log of x. Get rid of that. So in order to get rid of that, just differentiate. How to differentiate? Use integration by parts. Okay? For example, if I already have x here, how can I do that, right? I don't like natural log of x, but it's there. So the only way to get rid of that is to differentiate. Okay? How can I do that? I know if you let u to be natural log of x, if I differentiate, I get 1 of x dx, right? But how can I express like u and dv? Then if I interchange, it's two variables. I can du, right? Du I can be 1 of x. Right? So I needed to know what is x dx dv, right? So dv should be equal to x dx, this part. I think it's easy to figure out what is v, right? If you want to express that integral in the form u and dv, then dv should be equal to x times dx. But how can I get v? And I think it's easy. V is going to be half of x squared, okay? And the plus constant, but don't need a constant here. Right? If you still don't get it, and you can put the integral on both sides, at least you can evaluate this integral. And that side is v. So v equals integral x dx, right? Okay. So, and then again, you will get plus constant. So you drop the constant. You just need a 1v. All right. So this is so now you can interchange these two variables and v and du, right? By integration of parts. All right. So what is u? U is natural log of x. What is a v? V is half of x squared, and then half of x squared. And du is just going to be x dx. Okay. So you simplify a little bit. I prefer to move x squared to in the front of x, to the front of x, the natural log of x. And I have here 1/2 x squared of x is just x. So the entire derivative of x is half of x squared. Okay, half of x squared gives you x. And don't forget the constant. So this is the answer. Right. Remember, when you differentiate natural log x, you really changes the type of the function completely. You change the function to a power function, which is x to the -1. Okay. You don't like natural log x inside the integral. Okay. But here's a different story. E to the x is more friendly function. We like it. We love it. And if you want to differentiate, you're not going to change it at all. So derivative of e to the x is always e to the x. It's still there. You cannot kill it. Right? So don't even try to differentiate to get rid of that. You're not able to get rid of it. You can't. It's not. You cannot change the type. Like a computer game. So there's some things you cannot change it no matter, right? You can no matter how do you do that. You know, some can touch it, just change it. Right. So this is not changeable. And well, if there's no x there, it's great. It's already find the antiderivative. So this time, actually, we're going to get rid of x. We don't like x. Okay. So this will be u. That will be dv. How about that? Yeah, you have to decide which part is u, which part is dv. So u is x. Okay. And the dv should be e to the x dx. And I think it's obvious v should be e to the x. Right? When you differentiate, you get e to the x. Okay, that's great. So now, you will get uv minus v du. Okay, uv is going to be, u is x, v is e to the x, minus v is e to the x, u is just x. Whoa, that's it. So x is gone in front of, the x in front of e to the x is gone. That's great. We kill the x instead of kill the e to the x. Okay, it's different from the previous example, opposite way. The previous example, we don't like natural x, so we want to get rid of that. And we can do that after differentiate. Okay. So the antiderivative, e to the x is still e to the x in plus constant. Right, so that's the answer. And even x squared there, you can do this, you know. Yeah, by similar ideas, you can integrate x squared times e to the x. All right. So similarly, if we have e times 2 to the x dx, this is the same idea. Okay, because 2 to the x is also exponential function. Okay, you needed to find out the entire. This is going to be dv. Okay, this is a u again. But when you differentiate, yeah, so u equals x, dv equals 2 to the x dx. So what is v? So v is going to be integral 2 to the x dx. The antiderivative of that function is not just 2 to the x. Do you remember that? Yeah, 2 to the x, I think, divided by natural log of 2. Yeah. Remember, the derivative of a to the x is going to be a to the x times natural log of a. So the antiderivative a to the x will be a to the x divided by natural log of a. Okay, so this is we know that. Okay. All right. So that's a slight difference. The rest of them are the same. As long as you can figure out what is v, then that's uv minus v du, right? We will get u, then v is 2 to the x natural log of 2 minus 2 to the x natural log of 2, and du is dx. The natural log of 2 is a constant, so you take u is u is x, so put x here. Okay, so natural log of 2 x 2 to the x minus natural log of 2. The integral of 2 to the x is also natural log of 2 to the x, so plus constant. This is a part. It's antiderivative of 2 to the x. Okay. Let's do the next problem. I remember we did it for the natural x, right? Now this time I put a square there. It's okay, square is square. We'll do the same way. We want to differentiate. Probably cannot reach the goal in one step. Let's see. No, I have no other ideas here, right? Instead of using the integration by parts. So u is going to be natural log of x squared, v is x. But integration by parts, it's not the unique method to evaluate integrals. Do not use the same tool to solve all the problems. Okay, let's try, okay? So it's gonna be u times v minus v du. Okay, let's put a detail. U is natural log of x squared x. Sorry, this v is here. So v is x, right? Now I'm going to differentiate natural log of x squared. It'll be twice natural log x. Then the derivative of natural log is 1 of x. Right? So dx. So clearly x cancelled out, you get the integral of natural log of x. Then you apply the same method to the integral of natural log of x. I think we already got that. Integral of natural log of x dx is going to be x times natural log minus x plus constant. Okay? We already got that. So all you have to do is just put it in x natural log x minus x plus c. So that is answer. How about this? Arctangent x dx. I look at all the formulas listed in the book. I do not see some formula whose derivative is going to be arctangent to x. I know the only formula we know here is derivative of arctangent x, which is 1 over plus x, right? But we are doing the opposite way. We want to evaluate the integral, not a differentiated function. All right. The integral and derivative, they are the two things opposite to each other, like a kind of like an inverse to each other. Okay, I know when natural log meets exponential function, that cancels out, right? And the same here. You see, similarity is, you know, a chance to compare it, but it's not exactly right. So e to the natural x is going to be x, right? And the natural log of e to the x is going to be x, right? And the similar idea, e and natural log, they're inverse to each other. But integral of dx is also going to be x, right? Yeah. Okay. And of course there's a constant here. Okay. So this is a like whenever they meet, because this is a very simple integral symbol and dx is differential. Okay, they're canceled out. Okay. When you integrate a function, power function, you increase the power by 1. But when you differentiate the function, you decrease the power by 1. Okay. All right. So now how about this? I have no clue, right? But at least I can try to use the derivative. So this part is u, that's part of dv. So can uv minus v du, okay? This is the only way we can try. All right, let's do the next. U is arctangent x. If you want to write x after that, you have to put a parenthesis over this. Okay, otherwise it's easy to get in, slide into the function. Okay, messed up. You have the parenthesis, okay. Minus v is x. Now, what is the derivative of arctangent x? I already gave you here. It's 1 over 1 plus x squared dx. It's not too bad. You get an integral. You get an integral x over 1 plus x squared. Can you evaluate? Okay, when it's x over 1 plus x squared, you can evaluate using substitution. Okay, so you let, let's w to be 1 plus x squared, not x, not the x squared, 1 plus x. dw equals 2x dx. All right, so this is going to be, here's w, x times dx is half of w. Half of dw, yeah, half of dw, right? Yeah, x times dx is a half of dw. So now, that's entire derivative of this is going to be minus 1/2 natural log of absolute value w plus constant. Absolute value w, okay? xw could be negative, maybe in general. But here, w is always positive, so absolute value can be removed. So you will get natural log, replace w by 1 plus x squared. Okay. So that is the answer. We did not know the antiderivative will be in this form. I usually get 2 terms here. But the function, original function is simple, just arctangent x.
Would you get a different answer if you did the inverse of tangent and then solve for the integral?
If you exchange that?
So if you exchange the arctangent for its inverse.
For DUV?
No, for tangent.
I cannot evaluate the integral. That's what we begin with. The integral of arctangent x dx, right? There's no such formula you can quickly get to the antiderivative of this function. So
Well, I'm talking about finding antiderivative. I'm talking about taking the inverse of tangent.
Inverse of tangent. This is already inverse tangent. Yeah. Very well. Yeah, I've tried. Yeah. So, you begin with very simple, just one single function. You cannot touch it, basically. You cannot change the function. It's an inverse function. Right? Inverse function is only defined in the abstract way. Cannot be expressed in terms of any other well-known elementary function. It's not like a inverse of hyperbolic tangent x. Then inverse hyperbolic tangent x could be expressed in natural log, right? In another elementary function, not the inverse function. Okay, but arctangent x is just a function you cannot separate, cannot rewrite it. But when you differentiate, you do get more lower level elementary functions. That's 1 over 1 plus x squared. Yeah, when you classify elementary function like, those are you're very familiar with, like power function, polynomials, rational functions. Those are the lower level, okay? Elementary function. The next level is exponent function, natural log function, sine, trigonometric functions, right? Those are the functions that actually in the history was introduced much later. Human being understood the polynomials first. Then after that, we're talking about inverse function. So inverse function is even more abstract here. How about that? Okay. Then later on, in some textbooks, you have a very special function called the Bernoulli function. There are some special names there, okay, for specific problems in engineering. Right? Hey, all right, so I don't have any other ideas to solve this problem except for using integration by parts. Right? But if you have some better idea, you can show to me and take a picture, send by email to me. I can look at it. It's convenient. All right, so now this is our one, okay? How about integral of sine x is okay, right? Integral of arc sine x maybe maybe a little bit difficult. Okay, so let's look at integral of sine x. We know that, right? It's going to be negative cosine x. Right? Integral of cosine x will be sine x. But let's see if we're able to evaluate the integral of arc sine x, right? It's like the integral of arctangent x. There's no formula for the antiderivative. Of course, at the end of the textbook, you could find some formulas, but there's too many formulas. Human being, we have a biological brain. We cannot memorize all the stuff. So, okay, it's not like a computer hard disk driver. You can memorize all the formulas. Okay. But in the future, could be, right? Then in the future, there'll be half man, half machine. Right now, your cell phone is separate from your body, right? In the future, cell phone is not part of it, separate part of your body. So you can always get all the data right away. I can see that. Okay. Who knows, right? People already claim that in the future there's no cell phone. It means no cell phone like putting in hands. Invisible. Okay. Maybe when you're walking, you already charge some parts of the machine in your body. Then just call your father, daddy, then immediately you can hear the voice of your daddy. But what? Okay. Then I don't know whether how can we give a test, okay, during the class. Right? You math department still have policy during the test, during the quiz, no cell phone, no iWatch, okay, and no any electronic device that you can put on the table. But we still find out 5 on the final exam when we're grading. How do we grade the final exam? We grade final exams. One instructor grade 1 page for all sections. And when instructor just brought 7 copies of that page and final 7 students gave exact same steps of the solution. And we're trying to figure out what's going. Exactly means like a 7 steps for the solution, right? And then the 7 students, no, that's 5 students, yeah. They give us 7 steps. The first 3 steps already on the left side, then move to the right side. So the 4th step is on the right-hand side, exactly the same. And then the missing one equality when you copy it, and the equality is gone. So very identical. So sometimes, I don't know what kind of technology they're using. Okay. All right, so this is and then the chair called them, send email to them, please come to my office. First of all, they went to the office, they don't question them. They just say, here's a piece of page, and just 1 sentence. Did you cheat on the final exam? Yes or no? And sign your name. That's it, that's the first step. Then student come to my office, asking me, how can I answer the question? Well, that's a stupid question. If you cheated, just say yes, if you know, no. Okay, that's it. Anyway, so this is integral. And I think it's the only way we can try is differentiate, right? Do you still remember the derivative of arc sine x? I think this is all right. Yeah, that's what I remember. Okay. So let's try to see if we can do that. And then this is a u, that's a dv, okay? So we get uv minus v du. All right, so this is going to be, u is v is x, right? So arc sine x minus x, then the derivative is going to be this. So you end up with a similar expression. The only difference here is the square root of 1 minus x squared. But still, there's x squared there. It's good. Because you can use substitution to evaluate this integral. So you let w to be 1 minus x squared, not x squared, so 1 minus x squared. dw is going to be negative 2x dx. Okay? So now you get, this is square of w, and x times dx is negative half of dw. Okay. So what is the antiderivative of that function? I probably have to rewrite again, and the plus half, square of w is w to the negative 1/2 dw, okay? Then you use a formula for the integral. This is a power function, okay? So it's going to be, it's going to be 1 minus negative half, w to the 1 minus negative 5 plus constant. Okay, we're done, okay? You simplify it. 2 is gone. And w is going to be 1 minus x squared. So actually just 1 minus x squared plus constant here. X squared 1 minus x squared plus constant. All right, so we did a similar. So if we put a problem, similar problems on the test, I hope you're able to do it, okay? Now, what happens if I already did the x times natural log of x, right? X times e to the x. How about x times sine x dx? I give you 1 minute. I wish you to figure out how to do it. Yeah, we already did it. You see, remember, we already did the x natural log of x, right? Dx, x e to the x dx, right? We did this, right? It's probably in the same, in a similar form. But those two problems, we did it in two opposite way. They're not, yeah, we are not using exactly the same idea to solve the problem. But integration of parts, yes. But the way we choose u and v is quite different for those two problems on the right-hand side. Now you have x times sine x. Right, so we don't like x there, so you have to get rid of x. That's the whole point, right? So when you differentiate x, you get rid of x. So this should be dv, that should be u, right? Yeah, you know, if you make a long choice, probably you cannot solve the problem. All right, if dv equals sine x dx, I think v should be equal to negative cosine. All right, when you differentiate, you get sine x. All right, so uv minus v du, then you get u is going to be x. V is cosine x minus negative cosine x, and dx. So x is already gone in front of the trigonometric function, right? So you get negative, oh, sorry, there's no integral here. I don't know why I put the integral here. Yeah. So it'll be negative x cosine x plus, this will be the integral cosine. Integral cosine x is sine x, right? So that's why you get negative x cosine x plus sine x. So sine x is similar to e to the x. So if there's x in front of e to the x, you have to differentiate x. So if there's x in front of e to the x, yeah, in front of sine x, yes. Okay, so sine x and e to the x are in the same situation. Natural log is different. We don't like natural log of x. We're trying to get rid of natural log of x, right? By differentiating. But how about sine x times e to the x? Then what? It's the same position. Sine x e to the x. Okay. So let's do it. You can choose, yeah, which one you want to choose, right? So doesn't matter, I think. Let's try this. That's no other choice, right? So we get UV minus V du. And UV is going to be, yeah, UV is going to be, yeah, what is the V? V is e to the x. Yeah, U is going to be sine x, okay? So sine x e to the x minus e to the x, and the derivative of sine x will be cosine x dx. So what I did here is I changed sine to cosine. That's it. I did not simplify the integral. Still at the same difficulties at the same level, right? Yeah, these two at the same level, you know, the only difference is sine and cosine. But I'm going to continue work on that because I know other way to go. So let me try this. Okay, so if you do this, you will still here u equals e to v equals e to the x, u equals cosine x. So uv minus v du, right? So let's do it. U is cosine x times e to the x minus v is e to the x. When I differentiate cosine x, I get negative sine x dx. So I get cosine x e to the x plus sine x e to the x. So I get this back. It's like a cycle, right? So you from sine, you get cosine. From cosine, you get sine again. Are we able to find? Are we able to solve it? I think when you look at the science possible, okay? Why? I'm going to put this here, okay? So the integral of sine x e to the x dx is going to be sine x e to the x minus cosine x e to the x plus, right? Why this can be done? Because now I have sine x inside, but this two sine x e to the x is not cancelled out. They do not cancel out. That's a good part. They do not cancel out, okay? Minus sine x, it's negative. So I can move this term to the left-hand side, get double and divide by 2. So the integral of sine x e to the x dx is going to be half of that. And the plus com. This is the most complicated problem. So, okay. So this is yeah. So you can double check when you differentiate, and by same idea, you can get the formula for the integral of cosine x e to the x. Okay, you have to add a constant here. Yeah. So this term. Yes. So integration by parts applied here twice. It's not a complete circle. You're coming back with a negative sign of integral sine x e to the x. Therefore, you stay able to solve it. There are similar ideas for the problems like like cosine, like integral of. Yeah, similarly, you can. I'm not going to work on this one. We're going to get take a quiz. By similar idea, you can try to integrate these two. Okay. When exercising, when you have a time, when you get home, you can look at this. Okay. So those are the two problems. Use the same idea. You get, yeah, you can, you probably have, no, you don't need to use substitute, just use integration parts. But you have to apply the integration parts twice to get the answer. Okay. So let's stop here to take a quiz.